Hello, everyone. Welcome. We're going to get started with the webinar in just a few minutes to give folks a chance to log in. Welcome, everyone. Thank you for joining us for today's webinar. My name is Liz Marks, and I'm the Director of Product Marketing at Advanced Environmental Monitoring. AEM is a family of innovative environmental brands delivering integrated end-to-end solutions and services to help our customers mitigate risks, improve operational efficiencies, save lives, and live better. Today, we're presenting After the Smoke Clears, implementing a post-fire HydroMet monitoring system. Just a little housekeeping before we get started. All attendees will be muted during the presentation, but we're eager to respond to your questions. If you have a question at any time during the presentation, please use the Ask Questions button to type them in the question box. We will review all of your posted questions later in the webinar. After the webinar is over, we will be sending out a copy of the presentation along with a solution overview to all of the attendees. If you have additional questions or want to learn more about AEM solutions, please feel free to contact us after the presentation. We are excited to have two presenters today, Nathan Baskett from Sonoma Water and Jim Wellman from AEM. Since joining Sonoma Water in 2007, Nathan has worked in the Water Resources and Planning Group as a GIS technician, junior engineer, and hydrogeologist. In addition to helping manage Sonoma's OneRain alert system, Nathan's duties include water supply planning, establishing and maintaining groundwater and surface monitoring networks, floodplain modeling, and developing groundwater sustainability plans for 3 groundwater basins. Nathan is also currently pursuing a Master of Science in Geoscience with a concentration in Applied Meteorology from Mississippi State University. Welcome, Nathan. We also have Jim Wellman, who is the U.S. Hydrology Specialist at AEM and also had a career with the U.S. Geological Survey. Jim has become highly experienced over his career in analyzing and making decisions that improve hydrology methods to collect, monitor, process, and publish hydrologic data. Jim has developed, designed, and enhanced many complex hydrologic networks using advanced hydrologic monitoring and real-time data processing techniques to provide critical streamflow data which are vital for protection of life, property, and the environment. Now, without further ado, I'm going to turn the presentation over to Jim.
Thanks, Liz. I appreciate the introductions. And again, we appreciate everybody attending today's webinar. Many of us at AEM companies, we got into this profession to make a difference, to have an impact, and passionate about our work. We hope today is very useful for you to point out the post-fire considerations, the post-fire HydroMet system, and best practices in planning. And also Nathan's input from Sonoma County, their usage case. To start off today, we'd like to start off with a poll question. So if you can take a few minutes, and have you ever experienced any post-fire impacts such as flooding, debris flows, water quality, or others? Okay, thanks for the reply. And we had good response, 69% with yes and 31% no. Well, I appreciate the input and feedback. So to start out with our first slide, we just want to set the background of seriously a number of acres burned from 1984 to 2020. When I first look at this graph, you know, the period from 1984 to about 1998 to 2000, the burned area as far is you know, right around 2 million, some less, but you know, it definitely is a big difference from 2000 or 1998 on. And one of the things that we see is the increase of the number of acres, and then also the severity. If you compare the severity in these regions through this period of time, there's definitely a big jump in the severity. We know that we've had increased acres burned in the last 2 decades. And also the wildfire season has been extended to this as well. You know, the natural cycle of extreme drought, wildfires, and floods, and then floods. For current data, you know, number of active fires currently is 79. Burned areas currently is 5.6 million. And the number of fires this year so far is 44,650. If you look at the 10-year average, the 10-year average is about a little over 6 million with 44,000 fires. And we've already exceeded the number of fires. And with September, we're well on our way to meet or exceed the average number of acres burned each year. So this kind of gets you a background of the areas burned throughout the last 30 years. Really want to move into the post-fire hydrology. Intense wildfires produce, we know, loss of vegetation. The combustion of vegetative material can create a gas that penetrates the soil profile. As the soil cools, this gas condenses and forms a waxy type coating. Hydrophobic soils do not form in every instance. Certain factors contributing to their formation are a thick layer of non-living organic debris such as leaves, needles, bark before the fire, a severe slow-moving surface and crown fire, and coarse soils such as sand or decomposed granite. Fine soils such as clay are less prone to be hydrophobic. Hydrophobic soils repel water, thus reduces the soil permeability or the amount of water infiltrating the soil. Infiltration, soil moisture storage, and groundwater recharge can be altered. Wildfire can drastically alter watershed hydrologic response with substantial effect to annual and seasonal water yield, peak flows, floods, base flows, and timing of flows. You can have extensive soil erosion, sediment loading, and debris flows and dams. Understanding the hydrologic response is paramount for effective risk management and mitigation of post-fire hazards. Other considerations are water quality of the basin. Approximately 80% of the U.S. freshwater resource originates on forest land, and about half of the water supply in southwestern United States is supplied by water from forests. Thus, the water quality potential impacts can be significant. Watersheds can be altered through mobilization of sediments, nutrients, dissolved organic matter, which can have a short and long-term impacts of water supplies, and even straining the capability of downstream municipalities. Some of those impacts are increased sediment loading into water supply reservoirs, which can affect capacity. One of the things you may consider if you have an influx of sediment is consider a hydrographic survey to verify the reservoir capacity. or you may consider establishing a sediment monitoring plan. Another impact is increased turbidity. It is caused by the presence of suspended and dissolved matter such as clay, silt, fine sediment, organic matter, and other organisms. It can strain treatment capacity, capabilities, and increase cost. Also, you may have source water chemistry changes. In some of these, you will force the entity to seek alternative sources of water where their system is impacted either by sediment or water quality and their treatment capabilities. So they may have to look for other sources of water. Another impact is increasing loading of streams with nutrients, dissolved organic carbons, major ions, and metals. If your reservoir does become eutrophic, which is a rapid reproduction of algae and plankton, it can decrease the dissolved oxygen concentrations and have an effect on the fish and other species. You may want to consider reservoir and inflow monitoring of nutrients, determine the health of the reservoir. Other impacts are rock and mudslides. Post-debris flows are particularly hazardous because they can occur with little warning, can exert great loads on objects in their paths, can block drainage ways, damage infrastructure, and endanger life and property. Also, agricultural impacts can be significant as well, which can damage orchards, crops, livestock, and infrastructure. Even degradation of air quality can damage production of certain crops as well. Some of the public safety impacts, as we mentioned, if you have a large severe fire, your watershed response may be affected. Could increase the risk for flash flooding downstream. As we mentioned, it can alter response with increased runoff, greater chance of downstream flooding. You may have recreational concerns after the fire. There's going to be people coming into those forest or recreational areas. Also, road safety. You may have floods get inundated from severe flooding or even debris flows over the roads. The relationship between wildfires and water, it's a complex issue. It's not easy to manage. The one thing we know is that dual challenges of wildfire intensity and water scarcity in the West aren't going away soon. It's really important for people and users downstream to recognize potential impacts and the relationship to upstream forests to better manage their water resource. The other impacts is to irrigation. You can have the timing of flows can be altered. As we mentioned, the water quality and sediment issues, which can have an impact on the irrigation infrastructure. So we covered some of the impacts that you could potentially have. Now, how can we best monitor, track, and alarm on HydroMet conditions? These are some of the critical ones: water level stations. You may consider developing a network of water level stations, also groundwater station and moisture probes to better understand the surface water to groundwater interaction, as you may have some changes due to the permeability of the soils. Rainfall data and reports. It's important to understand the rainfall in certain regions to determine what the risk will be, and also evap calculation and leaf wetness. So these are some of them that we wanted to cover and just highlight. And also, one of the things we did at AEM, we've really worked hard to come up with post-fire weather, post-fire flooding solutions, whether it's a quick deploy unit to where you need to get a rain gauge to get rainfall data, when you can deploy that unit very quickly and rapidly, or compact stations to where they have a low footprint on the environment, and also smaller permanent stations as well. So really what this is, we've really come up with kind of a every type of solution for post-fire monitoring, whether it's surface water, groundwater, water quality. We've really thought through this, and we have the different solutions for you. The telemetry, it's incredibly important. One of the things that we've really worked hard again is to be able to come up with every telemetry that you could possibly utilize for anywhere in the country, whether it's real-time alert to, near real-time cellular, the GOES network, and we leverage other satellite networks as well. And again, we just want to, whether you have a station within the city limits or an extreme remote area, we have the telemetry to get that information to the emergency managers and appropriate personnel. We even have 4 sites down at the bottom of the Grand Canyon transmitting daily data. Some of the equipment we'll be utilizing is the rain gauges. We have assortment of tipping buckets to meet your needs. Also high resolution and very accurate rain gauges. All weather precip gauges for sleet, snow, and also gauge adjusted radar rainfall. And it's really it's a weather radar reflectivity that detects the relativity intensity as a rainfall in a polar coordinate. So we can get a good read on just the radar information. And that radar information is then utilized to whatever rain gauges you have in your network to increase the accuracy within the network or catchments that you have or basins. So if you have nothing or very little rain gauges in your network, the go-to is the GAR. It will go out and look at for whatever rain gauges you have in your network and actually be able to increase your accuracy. The more rain gauges you put in, the better the accuracy will be for rainfall for your entire basin. Water level sensors. Yeah, the non-contact radars, they've really been useful over the last decade. They're non-contact, so they're not in the water, and they can allow you to have small compact gauges on the infrastructure as far as bridges. They are probably the most accurate for medium and high flows. They also have less maintenance versus a PT or a bubbler. So we have a couple different versions. We're actually even making them smaller. Our latest is about 3 inches by 5 inches, but in particular for post-fire, you're going to have sediment changes within your channel. So if you do have a line out there, it could be buried or potentially ripped out, or just when it's buried, it's not working properly. The radar will really help you collect really quality and accurate data. Another new sensor that we have is a non-contact discharge sensor, where it has a built-in radar to determine the water level, but it also calculates the velocity of the stream flow. So if you know the area and the velocity, then you will be able to determine the discharge. Water quality has been a very important parameter to look at post-fire. One of the popular ones is, as we mentioned, with the turbidity is an issue. These are just deployed in the water to determine the turbidity. They can be used to help the water resource managers better manage their treatment facility as far as knowing what type of turbidity is coming in stream. And also they can be used to determine relationships with sediment and turbidity to develop loading as well. There's a relationship that you can determine and calculate sediment loads. The multi-parameter SON, which is really an instrument that you can have multiple sensors to record pH, conductivity, DO, and other parameters. And lastly, the sediment system. It's really a turnkey sediment system that really enhances the capability of the sampler. So again, you may have a need for determine what the sediment loading is. You can deploy these and take daily samples, but also the big difference of what the sediment system does is that it can activate off of turbidity and just not water level or water flow. So it can help you optimize your sampling procedure. And then the image on the right is this example to where you would put install a turbidity or multi-parameter SON. Situational awareness. Cameras have become an important part of what we do at AEM. We utilize them for dam safety. We utilize them to detect fires. You may want to use a camera for important infrastructure or a potential important stream station. What's also important is that we have the software as well to help you look at those images, store those images, and interpret what's in those images. It's been an emerging technology for us. It's also used by some federal agencies to determine flow, where they measure particle size going down the stream to determine the velocity. And the future use of is going to be artificial intelligence. Currently at AEM, we can actually see objects at our dam safety projects, and then the next movement would be to determine water level from staff gauge or known objects. So that's something in the future we're going to be working on, and I know other federal agencies are looking for is to deploy cameras to actually be able to determine water level. Flood management and watershed modeling is also important. It really helps you better manage the impacts of extreme events. You can produce inundation models to determine if roads are inundated or particular infrastructure is inundated. You can map flood threat and inform you of status information. Also at AEM, we also have road weather information systems. So if you do have potential water over the road or water over a structure, we can warn from flashing signs to barricades over the road. And ultimately, this is another piece to improve community flood resiliency. Just want to cover some of the best practices. You know, deployment and speed is important. You know, start the planning early. One of the things that I've done in the past is map the burn area, look at the severity of the area. And you also may want to delineate the watersheds, determine, hey, is this watershed in the severe area or are these watersheds on the very edge? And what's those potential impacts? But again, start early as you can in the planning process. Be realistic about what you need. Do you need a turnkey solution? Do you want to augment your existing system? Say you have existing systems, you just want to add to it? Or do you want to deploy it in-house? Rely on private companies to assist. And also, really most importantly, leverage surrounding agencies, assets, and experience. Reach out to your neighbors and see how you can partner. You may want to see, okay, what existing stations are in my watershed, analyze that data, look at any peak flows after a previous wildfire. So again, just reach out to your partners, work together, and then documenting the needs, try to understand all the impacts, You know, we highlighted the water quality, sediment, debris flows, and flooding. Just kind of holistically look at your watershed and determine what the impacts would be. And also bring all stakeholders together to discuss needs based on the impacts. And then design the system to work based on your needs. Things to consider for HydroMet development. Permitting can be time consuming. So again, the sooner you start on that, the better. You know, look at the right of ways, start early, look at any pathways you need to look at. And again, leverage what's available. There may be existing networks in your watershed that you can leverage. In installation, this make sure you go through the call 811 flag, and then just have a comprehensive discussion of how you're going to install the network. And then don't forget about the IT people. They may have to consider firewalls, DNS servers, and networking. Definitely contact our sales to start the discussion early. We're here to help you, to give you any kind of feedback, to work with you, to give you any kind of guidance on what works good in this situation. We're here to help you out in your planning process. And then if you need equipment quickly, we can expedite deliveries. If it's a critical situation, we can move your order up and based on its priority. And then just kind of wrap up my section here. Okay, we're going to do a quick poll. How prepared do you feel your organization for post-fire risks? Okay, we've got the poll results. So well prepared is 8%, prepared is 25%, somewhat prepared is 50%, and not at all prepared 17%. Oh, we appreciate the feedback again. And now I want to turn it over to Nathan from Sonoma County Water Agencies. Nathan has done a good job with the agency, and we appreciate him sharing his experience, and hopefully this will be helpful to you. Again, thanks again, Nathan, and I'm going to turn it over to you.
Great, thanks, Jim. Hi, everybody. As Jim just said, my name is Nathan Baskett. I'm with Sonoma Water. We are a water agency in Sonoma County, which is in the northern Bay Area, San Francisco Bay Area in California. And I'm going to go over and describe some how we use some of the technologies that Jim just described in implementing our own alert system that we set up after some wildfires that occurred in 2017. So to give you a little background of these fires, in October of 2017, during an extreme fire weather event, several fires broke out in the North Bay area, including Sonoma County. In Sonoma County, we had 3 major fires. They burned tens of thousands of acres, dozens of people were killed, and thousands of structures were destroyed. There's a particularly destructive portion of the Tubbs fire occurred in Santa Rosa and Larkfield area, where the fire just burned down through these suburban neighborhoods over Highway 101, completely destroying neighborhoods such as Coffee Park. So, the fires, it was a bit of a perfect storm. Like I said, it was an extreme fire weather event. October, the winds began to shift from our typical is offshore coast, bringing in cooler air, moist air. But these storms or these winds were coming from inland, and so they were very dry. very high wind gusts, over 40, 50 miles an hour. And there were several bursts of these high wind events that occurred all throughout October. So when the fire started in October 8th, they continued to burn for about a good 3 weeks. And another reason why that occurred is because while our rainy season begins on October 1, usually we do not start getting significant rain until November, and sometimes much later than that, including even into January or February of the following year. A good example of this is just this last year, after very typically long dry summer, the rain never really came. And so we've actually had about a third of our annual average rainfall occur last year. And this is on the back of another incredibly dry year the previous year. And so that has led to many problems relating to water supply conditions, but also our landscape is also incredibly dry at the moment. And it's primed for more wildfires if a fire were to start. So after the fires, well, actually, while the fires occurred, we were suggested to us by the National Weather Service that we should be setting up an alert system so that we could have an early warning system of potential new hazards that could come after the fires, including debris flows and flooding. So we set up gauges, 30 gauges, within and downstream the burn scar areas. These gauges are primarily recording rainfall intensities and accumulation, and also stream flow dynamics. But we also, in addition to those 30 gauges, we also leverage readily available data that's available online. So these are gauges coming from the National Weather Service, USGS, CDEC, and all this data is transmitted in real time via telemetry. We have a repeater station up on Mount St. Helena. And also more recently, we expanded the network to include 4 soil moisture and soil temperature sites. So that too gives us a better idea of what the surface water, groundwater interactions looking like. So when a person logs on to our Sonoma OneRain webpage, they are greeted with multiple ways to access the data. So if you're just concerned, interested in about, hey, what is the rainfall accumulation looking like right now, you can just easily access, hey, this is what's been going on over the last few hours or the last couple of days. You can also look at the data by interfacing with an easy-to-use map interface, or if there's a particular site that you're interested in, or a certain site type that you're interested in, like one of our alert gauges or just a weather station. And I'm also going to go in and describe how we set up these summary dashboards and these bookmarks and also setting up alarms and notifications. So this is when you're looking at our map interface. On the image on the left, this is everything, all those dots, those are every single station that we currently have in our system. So in addition to our 30 alert gauges, we're also pulling in data from National Weather Service, USGS, and on the right, that is just zoomed in on our 30 alert gauges. And also these areas surrounded by red borders. These are all the burn fires that have occurred in our area since 2017 alone. So this is an example of looking at our data by filtering for a specific sensor. So in this instance, we are looking at 2-day rainfall totals that occurred from a storm that happened in February of 2019. So this was actually the last big storm that we had in this area. And in fact, some of these gauges recorded more rainfall during this storm than we did all of last year. So this particular event did actually cause some flooding on the Russian River. And so what we have these visual cues set up. So each gauge has a threshold that we have put in there. So depending on what kind of station is, whether it's a rain gauge or a water discharge gauge, we can create these thresholds. So if a particular for instance, if a particular rainfall intensity, like on this one, is exceeded, it will, you can easily see, okay, these gauges are receiving rainfall intensities that could be leading to flash flooding or debris flows. So, so we could see the problem areas where those things might occur. And also with the map layer, we could add additional layers onto there. So in this case, we have in this example, we're overlaying real-time radar data, rainfall. So while we could see that the rainfall moving from west to east is fortunately passing over the area, and it's looking like it's clearing up to the left. So in real time, we could see, okay, we might be getting some relief here, or we could look farther out and see, uh-oh, we might be having some more rainfall coming. And in addition to rainfall, we could also bring in surface wind speed forecasts, wind gust forecasts. That's becoming increasingly important to us for monitoring for fire weather potential. This is an example of a dashboard. So if you're interested in a particular area, such as getting a good snapshot of what kind of flow dynamics is having at a spot, you can create these dashboards. So in this example, this is for Guerneville. Guerneville is a community on the Russian River. A few thousand people live in that area, but it's also has a long history of flooding. So going back to that February storm of 2019, this is a snapshot of what we were seeing at Guerneville. And you can see on the left here, flood stage has actually exceeded. So water is beginning to go over the banks and starting to flood the nearby structures. And you can also see in the middle panel area here, this is showing the 7-day stage and flow that occurred at Guerneville. And you can see that while the stage is still leveling off, or is leveling off somewhat, it's also still rising. So we could expect further flooding to occur. And you could also see this on the right side. These are all discharge that is occurring on the Russian River upstream. So as we could see that if the flows are still increasing upstream, well, we still got some problems going on downstream as well that we could expect to get worse. And unfortunately it did. And in this particular instance, in addition to having communities down there, we also have infrastructure all along the Russian River there. And we did receive some flooding and some damage that we had to do quite a bit of repairs and clean up for. This is just a bookmark of all the gauges on the Russian River. So when you're looking at this, essentially the lower the peak flows are here, these are upper Russian River gauges. And as the peaks get higher and higher, we're moving downstream. So while upstream, we're seeing, pretty impressive flows, about 15,000 CFS. By the time the flood wave makes it down to Guerneville, we are getting flows exceeding of 70,000 CFS. And so in instances like that, that's when you would expect alarms and notifications to be triggered. So like I was saying, for each gauge, we could set up a threshold. And so if it's rainfall, if a certain amount of rainfall is exceeded, alarm is triggered, and then emergency responders are notified of that triggering of the alarm. And the same thing can happen for a stream flow. So if a certain amount of flows at a river, same notifications could be sent off, or at a reservoir. If it looks like that it's going to cross a flood stage, alarms will be triggered. And so then that way, the emergency personnel can have an early warning system and dispatch their personnel. And so in recent years, we've begun to add more NOAA HMT sites. These sites are primarily located in the northern Russian River watershed. We've also added a wind speed and wind gust forecast. Once again, that's important to us for monitoring for additional fire weather conditions. And also this gauge in Venado is now reporting sub-hourly data, which is actually the wettest part of the watershed. So it's helpful in helping us understand what kind of rainfall dynamics we are seeing in the area. And we're also interested in lightning detection. Now, while lightning is very rare in our area, last year we were hit with an extreme lightning event, and it actually started several wildfires. And so as we move forward, we're interested in finding out when lightning occurs, where are they striking, so that we can actually, so that emergency personnel can actually send out fire crews out there to put out the fires before they spread. And as I've mentioned before, we're becoming more interested in fire weather conditions. So we are monitoring stations for fuel moisture content, looking at relative humidity and wind forecasts. And while for instance, we're expecting more fire weather conditions to occur next week. So we've been following the forecast pretty closely. Well, thank you, everybody. I hope this was got some good information out of this. And with that, I'll pass it back to Jim.
Jim, I think you might be on mute.
Our summary and key takeaways for today are post-wildfire conditions increase flash flooding and water quality risk. Also, HydroMet systems provide monitoring, tracking, and alarming on conditions. It's important to develop a plan as quickly as possible and be realistic about what you need. Design system based on impacts and all stakeholders' needs. And again, we appreciate everybody today joining. We look forward to the impact, your feedback, and communicating with you in the future. We have some time for questions.
Thanks, Jim. Thanks, Nathan. Let's now move on to your questions. Just a reminder that if you do have a question, now is a really good time to type them in the question box. We're really excited to hear, what kind of questions you might have and help you out with any questions you have concerning your post-fire HydroMet needs for your organization. We do have a couple of questions ready. Our first question is, probably this is a good one for you, Jim. How fast can a quick deployed station be installed?
Oh, that is a good question. The quick deploy stations will come in a box. All the components are there. So really, within 30 minutes or so, you can have a system up and running. You can have it pre-programmed in the off as far as your data logger. It's just a matter of assembling the tripod and putting on the rain gauge and activate your logger or telemetry, and you're good to go. So it's very quickly.
Okay, great. And here's another one probably for you, Jim. Can data and alerts be directed to the National Weather Service or other entities?
Yeah, that's a good question as well. So yeah, as I think in Sonoma County, they're doing that as well. So the data can come into Contrail and it can feed and to any entity. So yes, the data can be shared, and it can definitely go to the National Weather Service along with other entities as well.
Nathan, is that something that your organization is doing, sharing your data with others that are around you or other organizations?
Yes, we are. So you're definitely in the National Weather Service. So like I was talking about the thresholds, as soon as something's exceeded, they're the first to know, and then they take that and they put out their warnings through their interface.
Okay, great. And then I have another question that is for you, Nathan. Can anyone access that Sonoma OneRain website to view your system? Is that something that's publicly available for anyone to view?
Yes, it's all publicly available.
Okay, great. So that would be a great resource for anyone to go kind of sort of see what you guys have implemented and if that might be of interest for their organization.
Absolutely. And if anybody has questions when you go out there, my email is listed. And so feel free to email me or contact me if you have any questions.
And then we have one more question. What telemetry would be best for post-fire monitoring and why? That's probably a good one for you, Jim.
It's really dependent on you know, the needs, and then also potentially the location. If you want real time, then it'd be alert to. So that's one aspect of the answer. The other aspect, you could be in a really remote area, and alert to may be a problem. You may have to have some infrastructure in place to get that information back. So in that case, you would use a GOES application or other satellite. So which is the best? It's really depending on your location, and then your need for the most real-time data available. So there's really not a clear cut. It's dependable on the location, but you know, like I said before, sometimes you can use a multitude of telemetry for your region.
Okay, great. Well, those are the questions that we've had so far. So I think we'll close out the webinar. Thank you so much, Nathan, for participating, and Jim as well. We're really excited and hope folks will be able to reach out to us. As I mentioned in the beginning of the conversation, beginning of the presentation, please feel free to contact us after the presentation at marketing@ftsinc.com or the toll-free US number that's listed here. We will be sending out a copy of the presentation to all attendees, along with a solution overview with more information on our post-HydroMet solutions. Thanks everyone for participating and attending, and have a great day.